All right, back again. So start with our section announcement. ต้องเป็นโฟกัสคอนเทนต์นะโฟกัสคอนเทนต์ All right. Okay, start with the section membership. We have 594 members now, almost 600. I think we're getting better and better every month, as you could see from the graph on the right. Now we have 275 student members from 4 chapters. Chulalongkorn, Sulanari, Penop Songkhla, and Chiang Mai University. Not only to retain, but we also have a new member as well. We have more than 70 for this month. Another good news, I think it's probably come with the oil price now. We also have people pay their membership. So now we only have 56 labs. Last month we have like 65, I think. So it's getting better. And please also check if you haven't paid your membership, please do it. And of course, please also invite your colleague to join our meeting. And this will be opportunity to be in the event, as SPE Thailand is still the largest professional oil industry organization where you can regularly meet and greet in this relaxing environment. SPE membership benefit, I'm not going to go through all of this, but again, just to mention that we are very active section and the most active one in Southeast Asia. And this is a very good opportunity for you all. This slide is always the important one. And this is our sponsor that make us happen for tonight. So may I have a loud applause to our generous sponsors? Maybe. I think you all enjoy your food pretty much. So, all right. So for any of you, if you would like to see your company, logo up here, please contact any of the board member. So board member, can you raise your hand? Maybe you have to put down your spoon and knife first. All right, so you can reach any of us. And if you want to have your sponsor up here, and we appreciate your support. And of course, our society needs you all. Okay, without further ado, let me hand over the program to our program chair, Kun Kasian, who just finished the dinner, I hope. Then giving a speaker introduction. Thank you.
Okay, thank you, Kun Panit. Okay, so today we start a little bit late because I know some of you guys has to come through the rains. So thanks a lot for still joining us. Today is a bit different format, but if you joined us several months ago, we have done this before, but this time was not by choice. The speaker was here in Bangkok just a couple of days ago, but he had to actually rush back for some reasons. So we have to manage some changes, and then we do all this online meeting instead. He's here, hopefully still here. Otherwise, you listen to us playing the record. But anyway, let me start doing the speaker introductions for tonight. So our speaker is an experienced American Venezuelan leader with degrees in polymer science and international business. Speaker starts in the oil and gas business in the downstream business, but then he spent most of his career in the upstream instead. He joined Baker Hughes in May 2007 as a manufacturing and R&D chemist in the pilot plant. After a few years, he joined the headquarters technical support team as a fluid separation scientist, which gave him the opportunity to experience working in 20+ countries, facing different challenges related to heavy, medium, and light oil, as well as different water clarification projects. After many years in his team, our speaker led the production optimization teams for 2 years before moving to operations. He then led the North America Operations Support Team, which represents the largest operations of Baker Hughes chemical teams. In 2019, our speaker was assigned to lead Angola as product lines manager, where he had the opportunity to work with 100 plus teams, as well as work with several global producers companies. Currently, our speaker is leading an initiative called Production Solutions, which represent a unique approach to clients and internal challenges where the power of collaborative efforts between artificial lift, chemicals, and reservoir technical services enhances the solutions from a more holistic approach. Ladies and gentlemen, please a warm welcome to our speaker online, Mr. Carlos Diaz, Global Production Solution Director of Baker Hughes.
Thank you. Thank you, folks. I'm going to start sharing my screen now. Let me know if you can see my screen. And if you can hear me. Can you hear me? Thumbs up.
Yes.
Perfect. All right, folks. So thanks a lot for the opportunity to be a speaker on this important event for the Thailand SPE Thailand section monthly meeting. I wanted to apologize for not being there in person. I was actually there on Monday and unfortunately have to return to the States. I want to congratulate SPE for the 594 members, and something that is really important is about 50% of the members are students. So we have a new generation that still believe in our industry, and that is pretty important to all of us. So hey, hats off on all of you folks. So my introduction was already completed, but my name is Carlos Diaz, over 15 years with Baker Hughes, almost 20 years on the industry. I have been working in different countries in the world, and I have the massive honor to work in Thailand on different operations across the Gulf of Thailand, and where I learned a lot from a Thailand operation. I learned a lot from Thai folks, and I had the opportunity to meet a lot of you in those visits. I work for Baker Hughes, which is a company that believes in technology and is present in over 120 countries. Moving on with the presentation, I want to start with the safety moment. The safety moment is, I title it Focus on the Essentials. If many of you have been in Bangkok lately, you can see that there is a lot of rush on motorcycles, and some of the motorcycles drive on the sidewalk. So I was paying attention on the motorcycle, and I was not paying attention where I was walking to. And I stepped in a pothole, and I bent my ankle, and I messed it up. So I'm okay. I'll get better. But this is to me is a massive reflection that we need to be focused on the essential. We need to be focused on what we should be paying attention as well. So I know nobody want to be run over in motorcycle, but you can also have an incident for not paying attention on the essential. And this is a call for reflection, that keep up with what is essential. And on the environment will be exactly the same. We all have big goals. We see the motorcycle coming on the environmental. We see all the big monster that we have in front of us to 2050, but we need to pay attention on the essential. So this is my safety moment. With that, I don't know if I don't know if we can handle questions right now, but I want to move on, and we can have questions and answer at the end of the meeting. So production solution approach. What is production solution approach? Production solution approach is centuries of combined data, technology, and experience working in collaboration to approach operation challenges. So pretty much it's use historical data to predict the unknown and make best decisions. We all have a lot of data. Data are stored everywhere on everybody's computer. And we have fellows that have been on this industry for decades, and they learn from people that were before them. So what we are working on production solution is a collaborative approach where we can take advantage of everybody's experience and the data available. And using today's digital tools, we can make data to make more sense and approach the challenges in a better way. I'm going to turn on my pointer right here to show you on this bullseye graph that we have on this side. This is inspired on a book called Starting with Why from Simon Sinek. So we're starting with why to best work on what is important to us. Let me minimize my size right here or move to this side of the screen so you can see it better. So what we are doing right here, it is the starting with why is our why is lowering lifting costs. So we want to move hydrocarbons from the reservoir to the surface side at the lowest possible lifting cost. Again, that is our why. That's what we wanted to do. That's what we are working to do. So how are we doing that? So we identified 4 ways to get into that. The first one is maximize lifting and increase flow. What do we mean by this? I'm going to give you an example that might make sense to all of you. Maybe we can approach clean up near wellbore, and if we can improve oil production or gas production, we can definitely minimize the lift cost. I mean, we can produce more at the same cost or a minimum cost. We can minimize the lifting cost. The second one we have is reducing workovers and eliminating downtime. How do we do this? Tackling essential challenges that could be avoided, improving run life of artificial lift method like electrosubmergible pumps, gas lift, rod pump, will help us to have a direct impact on lowering lifting cost. We can reduce the environmental footprint by reducing workovers and eliminating downtime that improve, at the end of the day, cash flow for clients. Simplifying operation and reducing OPEX. This one is very close to everybody's day today or everybody's right now. And the idea of simplifying operation and reducing OPEX using data and automation solution. Then I want to make sure here we understand that the proposal is not demanning the industry. The proposal is not get anybody out of job. The proposal is repurpose the job we are doing and let artificial intelligence and automation to handle low-hanging fruits so we can be more efficient on the work we are doing. And I left to the end, but not because it's the least important. I left to the end because it's affected by all of the others, is lowering emissions and minimize HS&E risk. Why is this important to lower lifting costs? It's not, nobody want to hurt anybody, right? Nobody want to get hurt at the work. Nobody want to have a big spill. Nobody want to face any of those issues. However, those issues happen. So if we can minimize those by minimizing the exposure of the environment and the people, we also will impact the cost of the operation. Probably many of you remember a few years ago, there was a massive spill on Gulf of Mexico that almost got a major company out of business. We have been experiencing that as well in Alaska. We've seen it in downstream on refineries. So HS&E and environmental issues represent a massive cost. So that is the 4th leg, and it is one of the hows. We are trying to impact the lifting cost. And then is the what. What can we do to get to the house to at the end get into the lift to reduce lifting costs? So then it's all the tools that we can provide, and we can work in collaboration. So we're production monitoring, production enhancement, automation, analysis from reservoir, tailored chemical solutions, artificial lift system, reservoir analysis, maybe analysis that can help us to change the artificial lift method from gas lift to artificial to ESPs or vice versa. So that is what we are working. So again, production solution is a collaborative approach that leverages the expertise, reputation, and network of different product lines combined with digital tools to best approach the challenges from the client. That's what production solution is. All right, and after discussing with several operators and fellows in the service companies, we understand there are 3 main legs that can definitely affect directly the lifting costs, and we need to approach it on those 3 legs. Those three legs are tailored solutions. We understand the challenges are unique, so the solutions must be unique. We cannot keep seeing the solutions as a commodity, right? So for specific challenges, we have to have specific solutions. The second leg is digital and automation. We understand that we have to be agnostic to lifting mechanism, but we have to provide visibility, remote control, autonomy of the production, and at the end, predicting what can be predicted. And the third one is reservoir solutions. So everything we're seeing on the surface will have a better impact if we can understand the challenges from the reservoir. So how high we can go depends on how low we can go on this case. So the reservoir is the third leg. So going with the tailored solution, here it is. Let me move to this side of the screen so I don't disturb you folks from this side of the screen. Okay. So what we are seeing right there on the screen is an opportunity that we have to work in a challenge a client in Italy have. This is a well that it was drilled on a national park. As you can imagine, the challenges of drilling a national park in Europe is very expensive, is a very logistic intense operation. So this well have a dual system pump. In other words, you have two electrical submersible pumps in the same well. So if one pump fail, in the same well, the second pump start. So that was the principle of this one. So we're starting with this one as a case because this one is an SPE paper that will be presented next week in the SPE event in Galveston, ALCE, by E&I. The paper will be presented and it was written by E&I. So what happened over here was we start seeing using digital tools, our digital tool, the monitoring tool, we start seeing the different signals from the sensors of the pump and understanding the physical chemistry of the fluid. And when we combine it with the different signal we were receiving from the well, we understood the first pump was getting skilled. And what we were seeing was vibration where amp acting erratic or the power of the pump acting erratic. We were seeing differences on the pressure from the intake of the pump. So we start seeing all these and understanding the challenges. We approach the operators and pretty much explain them that the pump was in risk and potentially was going to fail fairly soon. Unfortunately, the first pump failed as it was predicted. Again, this pump was treated for a local chemical team, and it was treated with a commodity. So the second pump was exposed to the same environment. The first pump was exposed, and we start seeing the same signal, a noise on the vibration, noise on the amp, the different pressure, and we report to the client or to the operator, hey, what you are seeing, what you saw in the first pump is going to happen in the second pump and probably faster because this pump is being exposed to the same environmental that the first pump. So we were able to intervene the pump with a better tailored solution on the chemical side where we remediate first the damage already existing in the pump and then to follow up with a continuous treatment. So there, as a result, what we got was an increasement on the run life of the equipment from 200 plus days to over 1,000 days. And when they pulled the wells out, the pumps out after 1,000 days, the second pump was intact. And that was something that is written in a paper. I invite you folks to pull the paper. It is there, all the information on the economicals. So improving the cash flow for this important operator depends on the West Texas index. You see it's being very volatile, up and down, but depends on the price of oil. They save different amount of money and saving the operation at least $4 million in operation, affecting directly the lifting costs of this operation. The second case study we have right here, let me move to the other side of the screen. The second study we have right here, it is when you ask any technical person from electrical submersible pump, if you can name what are your biggest headaches on the operation, they for sure they're going to mention solid. At one point, the first, the second, or the third time, they will say solid. Solid is a big challenge for any lifting mechanism. So on this case, what we are seeing right here, we were facing sand that was coming from the formation. This is not frac sand. This is coming from the formation that started building up in the pump. And the historical data on this pump, the pump was lasting 90 days. That was the run life of the pump. And it was facing that problem for about 5 years. So we intervened with a surfactant. It's a special surfactant. And again, not going away from being commodity. So what we did was apply a very specific surfactant that have dual purpose on this. First was to move the solid out of the well without creating erosion on his way out. And second, ensure that the surfactant will not going to create surface issues. So as you can see here, after we started the field trial, the emulsion in the BS&W on the surface side went from being about 2% to be 0. So actually was helping, and all the sand was going with the water leg, and it was not staying in the interface. So what was happening right here, we were coating the sand with this non-charged surfactant, and it was coating the sand, preventing agglomeration of it, and allowing the sand to flow freely out, but the sand was coated on this surfactant, and it was acting kind of like a corrosion inhibitor, preventing the sand to create erosion on its way out to the well. So the trial started in November of 2021, and it's been still running. So we pretty much already have about 300 days, and 3 times more than what we have seen before. This is being extended to the different part of the field, and right now we have about 40 wells on this treatment, and it's been successful up to now. The third case that we have right here on Taylor Solution, again, we are still on Taylor Solution. I know it's a lot of information, but we're still on Taylor Solution. So the third case, what we're seeing right here, it is we are using inputs from the different sensor in the electrical submergible pumps, where the VSD of the ESP is controlling the chemical injections kit. So what we're using different parameters like downhole amp, intake pressure, vibration, and a bit others to manage the and we create an algorithm that manage the injection of emulsion breaker. So as a consequence, the chemical consumption decreased, and the performance of the pump increased. It got better because we were breaking the emulsion downhole and improving the performance and releasing the stress on the shaft of the pump, and the pump was operating way better. With this algorithm, it's important to say that this is conventional. Unconventional wells have different behaviors, but this is conventional. This was done in Ecuador. This is done in Ecuador, or the first one was done in Ecuador, and it's been successful up to now, and it's been applied in different places. And if we see on the other side of the screen, on this side, what we're seeing right here, it is using the same principles with this algorithm. What we have been able to do is, if you remember the case on ENI in Italy, we have been using the same data to create algorithm to control the injection. So why do I have to increase or decrease the injection of different chemistries? If I already know what to do, I can actually set it up in the controllers, and this key will act by itself. Some of the damage created over time. Some of the damage just pop overnight where nobody's watching, or we have way too many wells to take care of all of those. So why not to make a closed loop? What we have seen here is with the same algorithm, we have been able to control inorganic scale, and as well as asphaltene and paraffin, using different parameters and inputs that are well known by our folks. The second leg that I want to talk today, it is a digital and automation, and we understand on this one on digital and automation that we have to be secure. It has to be safe to manage the data of the operator, but also of the service company. It has to be agnostic to lifting mechanism, and we have a way to approach on this one that we want to be bringing to your attention in 2 slides. I want to start this one, and out of this slide, something that I really want to highlight is the 2 in certification. And again, data management is gold, is gold for bad organizations that want to steal data from operators and from service companies. So being able to be certified from ISO, it is important. We have a very secure data management and data management system, and we're pretty proud of it. And we want to make sure where our data is exposed, we want to be on the similar environment. Okay, folks, so getting more into details on this one, when we start, we understand that we have to have the data and automation deployment have to be on phases, right? I mean, this is our industry, especially in the production side, it evolves every day, right? And there is so many gadgets that appears every day. However, we understand that there are 4 phases that need to happen to being able to be more efficient and assertive when we approach data and automation. The first one is visibility. We understand that you have to have visibility around your field so it can be better managed. We want to have the chemical parameters in the same place where we see the artificial lift parameters. We want to have all the sensors that you have in your production, from your pipeline, from your vessels, separator vessels. We want to see the difference on the interface versus, and the temperature on the wells. We want to see it in the same place. We want to have visibility. The main thing, the first stop is visibility. After you have visibility, we understand that the second one is control, remote control. So enhance governability of the asset by remotely operate chemical skid using data library and controllers connected to production link. We can work also different parameters on the artificial lift. So we can actually operate. The idea is that we can operate from Bangkok, an asset that is moving right now in Gulf of Mexico. So we cannot control what we cannot see. So the first step is visibility, and the second step, it is control. After that, if we remember the case on that we have been talking on ENI or in Ecuador about the closed loop, if we understand what data is being used to control, we can actually close the loop and we can create autonomy. So chemical skids as well as the VSD from the artificial lift method can make their own decisions and optimize on that way the performance of the asset. And at the end, the last but not the least, we understand that prediction is where we are going with all the data we have collect up to now. We understand prediction is where we wanted to go. Actually, right now, there is a tool available that is called prediction failure analysis that help us to understand when an electrical submersible pump will fail, and is more or less 80 to 90% accurate. Why is this important? When you can predict your failure, especially on an ESP, you can best manage the logistics to intervene those wells. You can actually have a schedule and be ready to be efficient and cost effective at the moment you intervene those wells. And if you remember the first slide, is everything about lifting costs. That's our center, that's our why. On this slide, I'm gonna move to this slide. Sorry, I'm moving back and forth on these. So when we approach a chemical dosification or expense in any field, the way the majority of operators manage that, it is by dosage recommended, and it is a relationship between the injection rate and the chemical consumption versus the total production of the asset. The asset, by asset I meant a remote platform or the main hub or a field onshore, but normally it's the bulk production. So the challenge is that even when this could be very accurate, and many of the operators give a 10% delta. Another way to say it is, let's say we have 300 parts per million is our injection target. So if we are 285 part per million, we're okay. With 315 part per million, we're still okay. The gap is about 10%. That is acceptable in the majority of the operators. However, what we understand it is, even when this is a holistic approach from the entire field, it doesn't mean that all the wells are being treated in the same way. It is just the field. And as we know, every well have its own challenges. So what we're seeing right here, it is wells that have been overtreated, wells that have been overtreated, and wells that have been undertreated. And this is costing ton of money to operators and service companies, because we're trying to understand why the technology that is being applied is working on one well and is not working on the other well. So if I can say the chemical application has three ways to do it. One is you have to have the right chemical. Second, you have to have the right application. And third, you have to have the right frequency of the dosification. So the idea is that we can get all this and we can see it by well. How are we doing that? If you see in the top of this, we're seeing visibility, as we described earlier. We want to have visibility across the entire field. We understand that not all the field has to be on remote control, just part of the field, but you want to have remote control, especially on critical application, that is, or remote applications, and closed loop. With the closed loop, I wanna give an example of something that is going on the region right now in a major producer in Brunei. There is a closed loop application for H2S. What is happening right there, when you are going in your operation, and any of us go and get a sample of the H2S, you're getting a snapshot of that specific moment. You're getting how much H2S you have in that sample point at that specific time, and you adjust your chemical consumption based on that one. But to minimize the risk, you probably increase it a bit more because it's an HSNE issue. So what was done on Brunei was we installed a analyzer, H2S analyzer, for 3 phases. So what it does is it purge nitrogen through the fluid, extracting the H2S from the water, oil, and gas, and go through analyzer. And every minute it is taking a read and it's adjusting the chemical every minute. What we have seen is reduction in H2S, and the closed loop is injecting a 3-phase H2S scavenger. So what we're seeing is reduction on the chemical consumption, but also reduction on the H2S. So again, the main goal is to reduce lifting costs applying DEET and an automation gadget. So this is the example that we have in here. Hopefully I haven't get anybody to sleep yet.
Not yet. Okay.
And the third leg, folks, is reservoir technical services. Right, that right there is what we understand is the missing link, or the most promising link. Having information from the reservoir, it is an amazing tool. Everything we're facing in the production side was evaluated from the reservoir side. Everything we're doing today in the production side was probably resolved or was in someone's desk on the reservoir group. So we understand bringing that RTS or reservoir technical services into the table create a massive impact on this one. So when we're talking about reservoir technical services, one of my mentors, his name is Pat Jackson. He's a gentleman that has been in the industry on the artificial lift for probably over 30 years. He was telling me that there are 2 ways to run an SPE to an optimum point. 2 ways, and sounds very simple, but one is design it right, and 2 is operate it right. Only 2 ways to run it perfect. Sounds simple, but to design a pump, you have to have a lot of information, and we have to admit it. Information is not always available at the holistic information. So having reservoir technical team will help us to best manage the information. We have to best design pumps. However, in the operation side, also the reservoir technical services team can help us to get a better impact on the operation. And there is a paper, and I will send you the paper number and name through the committee of the SPE. But what happened was in West Texas, there is a group of operators that are operating the same basin in the same reservoir. There is, I believe there are 5 of them. They're using exactly the same equipment from our company, but the run life is completely different. And there was a paper that out of that, it was a massive study, and it's all about how those ESPs are operated. So it was an intervention from RTS team that helped one of the operators to best operate their system and increase the right life cycle of the ESP in about 60%. Production enhancement, we talk about production enhancement. It is important to understand that those brownfields that were already built can be maximized on production. And sometimes it's just as just cleaning near wellbore. Sometimes to understand and be more assertive on where to target those assets. RTS is a massive a group that can help us to identify those assets so we can all be more assertive. With this team on the RTS, also one of the biggest challenges we have in the operation and one of the biggest expense we have on the operation, go to again lifting cost, it is water, right? Managing water in the top side, in the production side, is very expensive. So it's something that we have been working with the reservoir team is how to best manage water. And the best way to manage water is not produce it. So if we can minimize the water production, that is a big impact. That will have a big impact on the lifting costs, and therefore is going to help our purpose, our why. So RTS, or Reservoir Technical Services, is also helping us with all this. So folks, I don't want to put you to sleep with in all of this, but the main message is that seeing the production side from the reservoir is actually one of the best things we have done up to now. So we move a bit faster on this one. We understand that this is not a selling speech, but we want to show results. I mean, all of this technical effort, all of this operational effort, and what you folks want to see is exactly what we want to see. We want to see savings, right? So this is a working completed with a major operators in West Texas, and as you can tell, I'm on a point right here. We have 3 different artificial lift method. We have rod lift, gas lift, and ESPs. And what we have seen is working in collaboration and bringing different technologies from different product lines is helping us, and engaging with RTS is helping us to promote and increase the run life of the different lifting mechanism on these specific operators. So on the rod lift, the increasement on the run life was about 57%, and it was mainly to minimizing the microbial the microbial impact. In Permian, many of the production is coming from fracking. Is a big deal right now in West Texas, in Permian Basin, and sometimes the water coming on the fracking is not treated for bacterial. So some of the reservoir has been contaminated, and the bacterial is creating iron sulfide, is creating different type of corrosion, and all that hurt the lifting mechanism. So working with the reservoir team, with the chemical team, and the artificial lift folks, in combination with the operator, we were able to identify the right solution for the right challenge, increasing 57% and producing $26.1 million to this client in about 5 years. The second one was gas lift, and again, as all of us been working in the production side, normally you don't have one challenge. Normally you don't have only scale. Normally you don't have only corrosion. Normally you don't have only paraffin. Normally you don't have only solids. So what we identified was many of these wells were facing multiple damage. So the approach on this system to improve the performance of the gas lift was to identify a combination of different solutions in one package of chemicals that were applied to this lifting system, and help the client to improve their performance by 53%, saving them $7.7 million. I wanna make sure also in the same message was with the same study we were doing on this one, we were able to minimize the usage of methanol on the gas lift system. The methanol is used to prevent hydrate on the gas lift system. So by doing that, it was it minimized the carbon footprint from moving large volume of methanol. The methanol is normally applying in percentage of the production, so that is not counted on the saving, but it was a big thumbs up for the environment, which at the end of the day is something that we are also very focused on it. And the third one, it is on the ESP. Again, solid control was a big deal. And on this case we were pretty much preventing the solid formation, and we increased a run life that was average 200 days for the entire field. It was improved about 56%, and the total saving for the client over a period of time was $56 million, which was pretty key and pretty good. But more than that, we learned a lot out of this exercise that we did with this operator. Folks, and this is not the last one, but it's almost the last one, and this one is actually pretty close to me, and as well as the safety moment, talking about the essentials. Everybody have big goals for 2030, 2050. However, there are low-hanging fruits that we can take care of today and can help us to minimize our environmental footprint and help us to be, as an industry, more competitive and best accepted in the society on today's world. So I'm gonna go with the first one right here. It is optimize energy consumption by improving fluid viscosity or drag reducing downhole. But what's happening right here, it is a case where in the Gulf of Mexico, there is this major customer or operators they're using the largest ESPs in the world. Capacity is 2,800 horsepower. However, due to the size of the power generator, they could only get to 2,200 horsepower. So the solution were two. One is you bigger generator and you burn more diesel, or two, when we get the holistic collaboration, is you reduce the viscosity of the downhole fluid. So now with the same power, the power generation, the same energy consumption, you can produce more, and that was what it was done. So that one helped, again, produce more fluid without wasting more energy. The second one right here, and this one I'm very proud of. I've been in Thailand, in the offshore Thailand, and I have seen how you folks manage your produced water, and I've seen the blue and beautiful water that goes under those platforms are almost never touched by any hydrocarbons, so hats off on you. But this is happening today, still in the industry, right? When the hydrocyclone get plugged, they bypass the hydrocyclone and not to plug some injector wells, or the injector well got to maximum potential of injection, the water is get overboard. And some hydrocarbons are dumped in the water. And with the volume of the water we're dumping on the water, we're dumping large volume or hydrocarbons. So what was done on this way to improve the injection performance was using different parameters like pressure of the well injectors, the delta pressure in the hydrocyclone, to circulate chemicals that help us to clean the liners, so the hydrocyclones could be more effective, and we could have cleaned the water way better. So we're very proud of that one. I'm very proud of Thailand. I was offshore probably for 6 months in Thailand and never saw a drop of oil in the water. So hats off on you folks. The third example right here, it is on the H2S. When you produce H2S, there is two ways to get rid of it. It is either you vent it or you burn it. So the idea is to prevent the H2S. Or you can scavenge the H2S, but when it passed to the point that you already cannot scavenge it, it's either burnt or vented. And the idea is, when we talk about the Brunei case, what we are doing on this is also preventing unneeded flaring. So if we can manage the H2S at where it's manageable, and not let the H2S to go to the point that is already in the scrubber and it have to be burnt, we can have a better impact on the environment. So very proud of that one. Let me move to the other side of the screen so you folks can see the other two. And those two are mainly, if you see in the top one, let me go over here. This one is, you probably are familiar with remote operations. When you are in the hub in Alpha, let's say Alpha is the hub, you have to go to Charlie, or you have to go to Delta, or if you are in onshore, you have to drive to the well to see some parameters, to see how the tank levels on the chemical consumption, the frequency of the pump, if the pump is airlocked, if the rod leaf is running well, if the gas leaf valve is optimum, etc. You send folks to remote operations just to verify things that could be controlled, could be verified and controlled remotely. So with tank level monitors, something that we have seen, it is that we can link tank level monitors with our tool production link, and that what we're doing is we can best manage the logistics of the boat and the trucks on refilling chemical tanks and performing remote checks on the chemical skid injection pumps. And the last one on this one is data analytics. And if we can predict, if we can best understand the life cycle of the ESP, we can understand when an electrical submersible pump is going to fail. We can best manage the logistic, and we can avoid HSNE risk. We can avoid having folks driving from point A to point B, especially now that everything is in a rush. We can minimize the CO2 impact of big crews going. So if we can extend the run life of an ESP, or if we can understand when that ESP is going to fail, we can be a lot more assertive when we set up crews to go and take action on workover. So we understand there are many other ways that we can impact the environment when we are working in collaboration. And when I say we, is all of us working in collaboration, we can have a better impact on the environment. And I deeply believe that, and we have seen it. And folks, I'm getting to the last one. I hope I haven't get many of you to sleep, but to conclude, I wanna say it again. The conclusion is production solution approach is based on integrated production technology is collaboration. We have to learn how to work together. We have to work together. Our main goal, our why is reducing lifting costs at the lowest environmental footprint. How are we doing that? Is maximizing lift performance, increasing production availability, simplifying operation. Again, we commingling different groups, different product lines into one bucket that can bring the exact solution to the challenges of the operation. The different tools that can be bring, we can have magnetic pump management ESP pumps that can create some energy to be reused in the same ESP, so we can minimize the energy consumption. We can have digital skid connected to the chemical that can be remote operated. We can have visibility. Neil wearboard cleanup is something that we definitely believe is a massive solution to increase production, and it should be applied. There are some cases where the entire crew is already right there. You're doing a workover, so it is just about to have the right study and have the right technology to clean the near well bore, and potentially you will be improving your production. Engineering and production expertise from the reservoir technical services can help us to best manage water, can help us with cleaning the near well bore, can help us with a better management of the ESP, of the gas lift. Is something else. With the reservoir team and managing the right data, they can be a better studies and minimizing the risk of changing rod lift or gas lift into ESPs that can help us to produce more fluid at the fastest way. With that, folks, I wanna thank you. Thank you so much for having me here. It has been my pleasure to be presenting to you. Again, I want to apologize for not being there. I regret not having dinner and a couple of glasses of wine with all of you. We got upgraded. We have Mr. Dave Dillon in the room and representing us. And thank you so much for the opportunity.
Thank you, Nicolas. Right, let's have a Q&A. Any question from the floor? Y'all still awake? If you wanna know. No question at all? Really clear? Yeah. All right.
Hi, Carlos. Thank you very much. Very good presentation. My name is Chris. I'm from Hunting, a product line called Organic Oil Recovery. Just curious, I suppose, more so than exactly the technical aspects you spoke about today, was do you mostly focus on brand new design for ES or production optimization, or are you also focusing as a company, Baker, in redesigning currently underperforming assets as well? So, for example, I don't know too much about Southeast Asia. I'm based in the Middle East. there's a lot of really old, really really badly underperforming PCPs, ESPs, rod lifts, and does Baker also focus on those, like trying to revamp old assets as well?
Yes, actually, really good question. Our goal it is to tackle all existing fields and new fields. I mean, brown fields are low-hanging fruits. We can definitely have a better impact on brownfield and the operation. What they were already built, that the investment is already there. So yes, we are focusing on both, and brownfield and existing assets, they're part of the initiative. Yes. Thanks, Chris.
Any more question? One. Sold. All right. I think you present very well and clear, so no more question from the floor. Thank you very much. Let's move to
Good deal.
our next. Sure.
Thanks a lot, folks. Enjoy your night.
Yeah. Right. Thank you. Please stand by. We're gonna continue with our closing remark. Okay, that might be great. Không phải không làm gìด้วยอะเฮ้ย Okay, let's move to the closing remark. Next will be the upcoming SPE Thailand section meeting. Next month, the topic would be a SPWA, a joint meeting between our two organization or two industry on the topic of through tubing casing inspection, methodology and case study from Kun Marvin Group. Who's here? Today is your survey, right? Check out how we're doing. No, like tricky stuff here. All right, he's the VP technology from Global, and the month after that will be even more interesting and exciting. So on 26th of October, we have SPE Thailand season opening and EMP Award, where we're gonna announce the SPE EMP Award projects for 2020 and 2021 as well. So we'll have a talk from Kun Mantri, CEO from PTPP, on the topic of the next chapter of Thailand Upstream. So please book and mark your calendar for that. Of course, on our neighbor, SPWA Bangkok chapter, we will have the talk on 25th of August on production logging and expert overview from Kun Colin Whittaker. So that will be here in Jasmine City Hotel in Sakura room. So if you are interested, you can follow our website and register. Another big event in 2023, we have IPPC from 1st to 3rd of March in Bangkok on the theme of balancing the energy landscape through innovation and sustainability. So stay tuned for that. That will be for next year. You can also check out sp.org Asia Pacific for upcoming event in the region. There are several workshops and also symposium here and conference if you might be interested. And I believe you know SPE Thailand. For some of you that might be new to this, you can check out our website, which is unfortunately not available at the moment. So don't go there. You might get some funny message. So I got to be frank, right? Come on. We have been hacked. Seriously, we have been hacked. I'm not sure what they're gonna get from our website, but anyhow, it seems that some. Yeah, we have some website. Not sure how much we're gonna get for that. 20 baht maybe. Uh, we have our Facebook page. You can pick up your phone and just take a photo of the QR codes over here. We have Facebook page. We have LinkedIn group and Line official. Those three still active. No hacker yet. So do not try. Hopefully they don't try to do that. Okay, let's have a lucky draw. Today we have a sponsor by SPE Thailand section. And lucky draw today is Body Works. I think it's Body Works. So it's the something for you in the bathroom. Something smelly. So unfortunately, I think Kun Carlos could not do a lucky draw. So may have his boss, right? Colleague, or your boss. Kun Dave talks to be an honor to do the lucky draw for today. That's easy job.
Mine doesn't count.
Yeah, you get mine in.
Ian Beardwood. Excellent.
Obi.
He's never here.
Is it here?
Comes for the drinks and then he leaves.
Hey, he's not here really. That's unfortunate. All right, next one. Hopefully not make a huge. This seems to be a kind of conspiracy here.
Take the whip. Connect energy.
Huh? Hey, congratulations.
Take a bath.
Time to take a bath.
I hope to see someone that's.
ไม่ไปถ่ายรูป
He can't go and take that. Give it a. I don't know like a thing. Frank and Frank? Yeah.
Right, congratulations. I thought it should go to ladies. See, not. Hey! Good work. I think it's the way that you told you that you need to take a shower. I'm not sure is that the way you take it, but yeah, that's why I think he told you to take a shower. So. All right, I think that's all for the lucky draw. Okay, so tonight we serve you hopefully many drinks, but if you still enjoy and would like to continue more, then you can go to the west floor on the ground floor. Then you can tell that you come from SPE, you get 2-for-1 promotion. So hope you enjoy that. And last but of course not least, can I have another round of applause for our sponsor for tonight? Right. Thank you very much. That is all. Thank you again for joining SPE. Thank you for you all to walk through the storm and then have a safe trip home. Yeah. You have.
Yeah, guys.
We will tie off a photo for you. First, Anupam will take your photo with your name. We have a nameplate, by the way, for you. That's your name.
Oh, that's
See that?
nice. Yes, sir.
Yeah, that's for your seat.
Thank you so much. Thank you so much.
Yeah, I need to take a photo with you now. Okay, Carlos, that will be all. Thank you very much.
Thank you.
Appreciate your time.
Bye-bye. Don't drink too much.
Yeah, time for your breakfast. Oh, you have your backdrop as well. Maybe you could not see.